When developers hear performance, they think faster algorithms, faster hardware, or clever tricks. But that framing already misses the point. Performance is not about how smart your code is. It's about how much work the machine actually does. The CPU doesn't experience your system as architecture or design. It experiences it as instructions. Every branch, every call, every layer becomes more steps. So before we talk about optimization, tuning, or benchmarks, we need to fix the mental model. Performance starts with an understanding what work actually means to a computer. At the lowest level, the CPU does something extremely boring. It fetches an instruction, executes it, then moves on to the next one. Billions of times per second. There is no understanding of intent, no awareness of abstractions, and no appreciation for elegance. Whether your code is beautifully designed or painfully ugly, it all collapses into this same loop. That's why performance problems are rarely mysterious. They come from asking the CPU to do too much work, too often, along the wrong paths. From a human perspective, this looks like a single action, but to the CPU, this line explodes into multiple steps: pushing a stack frame, resolving a method, possibly dispatching virtually, validating data, calling other methods, and eventually returning. None of that disappears just because it looked clean. Abstraction compresses how we think about code, not how the CPU runs it. This is why performance problems often hide behind beautiful APIs. The work is still there, it's just harder to see. Simple code wins not because it's more elegant, but because it does less. This line is obvious. You can almost count the work it performs. There are no hidden calls, no invisible branches, no deferred behavior. When code is simple, cost is visible. And when cost is visible, it can be managed. This doesn't mean all abstraction is bad. It means abstraction has a price, and simple code makes that price explicit instead of hiding it. In real systems, performance is dominated by flow. Most requests follow the same path again and again. That means optimizing rare cases rarely matters. What matters is shortening the common path. The CPU doesn't care how fast a calculation is if it happens after 10 unnecessary checks. The fastest instruction is the one you never execute. That's why performance thinking starts with asking, what path does execution usually take? This is one of the most powerful performance tools you have. Early exits shorten execution. If you can detect failure or irrelevance quickly, you avoid all downstream work. This isn't a micro-optimization. It's structural. You're reshaping execution flow so the CPU does less. This is why guard clauses, validation gates, and fast rejection paths show up everywhere in high-performance systems. They're not style choices. They're cost controls. Microservices naturally push developers toward procedural flow. Each request starts, runs, and ends quickly. There's no long-lived object graph and very little shared state. That shape rewards straight-line execution. Validate, act, return. This isn't because microservices reject object-oriented thinking. It's because performance, reliability, and latency all favor clear, linear execution paths. Distributed systems punish hidden work and reward boring clarity. Performance isn't about clever tricks or secret optimizations. It emerges from how you structure execution. Fewer steps, shorter paths.